Hi everyone, my name is Dominik. I work as a developer evangelist for a company called Twilio in Berlin. For those of you who don't know what Twilio is, just a quick side note, Twilio is a cloud communications platform that allows all of you as developers to easily integrate different means of communications, such as voice, video, messaging, sending SMS, etc., into your applications using just a simple set of REST APIs and client-side SDKs. But that's not the topic that I'm going to talk to you about today. Instead, as the title suggests, I'm going to talk to you about how I hacked my coffee machine, or rather how I turned this coffee machine of my flatmate in one evening with him and a couple of beers into this slightly modified thing. And we're going to talk a bit about why I did it, how I did it, or how we did it, and generally like what you can take away from this to later apply to your own hardware projects. So let's first talk about why. Why would I do this? The first thing was, well, it's interesting. Because when I was a kid, I used to love to take things apart and kind of play around with figuring out what actually goes on under the hood. And I have the feeling nowadays we don't tend to do that a lot anymore. My phone, I can't even take the battery out, neither can I do that with my laptop. And most devices are kind of made by the manufacturers nowadays the way that there is no way for you to kind of peek under the hood and figure out how it works. So we wanted to take something that we actually are able to look under the hood and understand what's going on. And then the other thing is we have in our apartment an Amazon Echo, and a bunch of different IoT devices that allow us to control the lights, control the TV, etc. But most of these are like purchased, and we wanted to figure out how much work it actually takes to build your own version that can interact with things like Alexa. And then the other thing, I tend to work a lot with APIs. So I love combining different APIs to build things like this. So if you go to that URL, you can vote a bit on which coffee we're going to make later, and then we're going to combine that API with the API that my coffee machine has now to then make some coffee. So yeah, why JavaScript? Typically when you think about hardware hacking, you think about using some C++, or even like more low-level C, to do the hardware projects, especially if you think about Arduino, for example. So why would I use JavaScript? And there are a couple of motivations for this. First of all, the last time I wrote C++ was in university, and I don't really remember most of it. I definitely don't consider myself a great C++ developer. But I know JavaScript fairly well, and it allowed me to do the coding way faster for this project, which later you'll see was very useful. Also, since this thing is supposed to have an API, we obviously need to have some sort of web server, and building web servers in JavaScript is pretty easy. Also, the project becomes significantly more challenging if you don't have much material to Google, and there's certainly less material about hardware hacking with JavaScript than there is about Arduinos, etc. And then the other thing is JavaScript and hardware, and this is my assumption, or was my assumption at that point, are really a good match because they're both essentially event-driven. You want to react if something happens. You want to react on a button press, for example, on your hardware, or you want to react on a value that changed. And these are the concepts that we work with every day when we write websites, for example, or when we handle backend code and we want to react on certain events like an HTTP request. And I had this idea of building something with JavaScript and hardware for a while, and I, like most people probably that ever wanted to do a hardware project, have a bunch of hardware at home, yet they never touched it. Similarly, that was the case for me. I had a couple of options that we could pick from for this project that were all suitable to use JavaScript and hardware. The first option was the Espruino. So Espruino is a project that targets to run JavaScript on the ESP8266. If you haven't been yesterday in the talk about hardware hacking or IoT devices, the ESP8266 is a small microcontroller that costs around $2 if you buy them online. And it has Wi-Fi in it, and the target of Espruino is to kind of run JavaScript on these devices. They also have their own devices, such as the Espruino Pico, which is the one that I had. The nice thing here is it actually has a USB port, which the ESP8266 by itself doesn't have. It comes with a web IDE, so you can flash the code on it very easily. Unfortunately, the Espruino Pico doesn't have Wi-Fi, which means the only solution for me to kind of make that Wi-Fi enabled was to solder an ESP8266 on that, which is a bit ironic because at that moment the Pico just becomes sort of the USB port for the ESP8266. And I didn't really feel like doing that on the Friday with like limited time. The other option that I had at home was the Tessel. So Tessel is an open source project and an open hardware project that is currently run purely by volunteers. And it has this piece of hardware called the Tessel 2. And the Tessel 2 allows you to, and that's the nice thing, run Node.js completely on this device. Meaning we can use the full Node ecosystem and leverage the different NPM modules that are around there to actually control everything, which is great because it makes writing a web server easier, it makes doing HTTP requests easier, etc. But we also had a third option, and the third option is called Johnny 5. And Johnny 5 is, contrary to the other two, not actually bound to a specific piece of hardware. Instead, it's actually just an NPM module that aims to talk to different pieces of hardware. Initially, this was Arduino via the Fermata protocol, which is a remote control protocol that allows you to talk to Arduinos, for example. But they have so-called I/O plugins for a vast majority of other boards, such as Raspberry Pis. I think every Raspberry Pi is supported. Particle electrons and photons, and a bunch of other ones, which again means that you can use the full power of Node, but it comes with a small caveat that, for example, if you want to use this with an Arduino, the Arduino isn't able to actually run Node, which means that you have to execute Node on a host system that is tethered to an Arduino, which isn't ideal if we want to make this a bit like self-contained. But the nice thing is there's an I/O plugin that allows us to combine the Tessel with Johnny 5, which means that on the one hand we can host the code on the Tessel and execute it directly there. Yet we can write portable code so that if I need the Tessel for a different project, I can simply port this over later to, for example, a particle photon that I have lying at home or a Raspberry Pi with just 2 lines of code change. So this is ultimately what we went for. Let's talk about how we built this. And a quick disclaimer, neither me nor my flatmate are electrical engineers. I had a couple of semesters, 2 semesters of electrical engineering, but I don't remember much of it, which you will see later. I think my professors will be very proud of my approaches. So obviously we approached this in a very, very scientific manner. We took a screwdriver and we just took away all the walls of that coffee machine and took a look inside. And directly we found some interesting pieces, namely in this corner, and namely 3 things. This was the control plate that had the buttons, it had a microcontroller, and it had this thing that I labeled as interesting cable. And the reason why this was an interesting cable is that it didn't only connect the control plate, which is basically what we tried to emulate, and the microcontroller, which actually is the brain of the coffee machine, but it was also detachable. So what do? We took the screwdriver again, took it out, and took a look at it. So that's the control plate, that's the buttons. You see down here in the bottom, I think there's a laser here. This is where you would connect the wire. And our idea was, well, we're gonna try to emulate this control plate, right? So we need to figure out what's the protocol that is being sent through the wire, so that we can fake that to the microcontroller and pretend like, hey, we are the control plate, we press the buttons. And to figure out what the protocol was, we connected the wire to this part, and then we took some jumper wires and jammed them on the other side and connected them to our Tessel. Because this way we were planning to kind of figure out what the actual protocol was. But in order to start there, we first thought of what we actually knew. And that was we had 8 cables, or 8 pins. We had 6 switches on the board and 7 LEDs. They're these like tiny things there. So that's what we knew, and then we had to make some assumptions. First of all, we need power, so at least one pin needs to be power. And then we need at least 3 pins plus power to simulate buttons, assuming that we have some sort of binary protocol. And then we need at least 3 pins plus power to control the LEDs. Again, on the same philosophy, but what the hell is the 8th cable for? But we figured let's give this a shot, and that's what we did by writing our first script. And here you can see how actually straightforward hardware hacking with JavaScript is. So basically what we did is we imported the Johnny 5 library as well as the Tessel.io plugin, and we then initialized the board with this. And once the board is ready, we just initialized all the different pins that we had connected by giving the pin that we actually connected it to on the board, and also specifying the mode that we were in. So mode 2 actually means analog mode, so our first attempt was to measure the voltage. Since we want to measure the voltage, obviously we first need to have voltage on these pins, and the Tessel has 3.3 volt and 5 volt. So again, we approach this in a scientific manner. We connected 3.3 volts to pin 1, which we assumed is power, and the LEDs lit up, at least 3 of them, but not as powerful as we wanted it. So scientifically, what do? Connect 5 volt, it works. So they lit up more like we expected it to be, so that was all right. But the problem was that when we were measuring these analog values tend to fluctuate a lot. And therefore, we weren't really sure whether they were changing because we actually pressed the button or whether they were changing because they were fluctuating. As a result, we switched to digital mode, which literally just meant that we switched the pins back to the default mode. And doing that, we were now able to just read high or low, but that was way more precise for us. And we were able to figure something out, namely that when we started pressing the buttons, 2, 3, 7, and 8 were doing something. They were all reacting based on these button presses, which meant that, hey, maybe they're buttons. Luckily, Johnny 5 has a button library that allows us to, button class that allows us to initialize them immediately as buttons. And this is where you can see the power of JavaScript. Instead of looping over and over and over again and checking if the value changed, we listen just on press and release, because that's the events that we're interested in. And we just log a message. So we did that, as well as kind of writing different scripts to turn the different pins on and off and seeing like if that changes some behavior. And we took notes, and we took more notes, and we took more notes. And you're welcome to read them, but they're not really useful. But we were on to something. Mainly, we knew that pin 1 was power because we actually were able to light up 3 LEDs. We also knew that it's roughly 5 volts, at least more than 3.3. We knew that pins 4 to 6 were actually, if we turn them high or low, we were able to turn the LEDs on and off. We knew 7 and 8 were actually reacting on button presses. And we knew that pin 2 was able to manipulate the upper 2 switches, and pin 3 was able to manipulate the left 2 switches. Which, all right, that's something, but it's not really useful, right? Because, well, we only have 2 pins that actually react on button presses based on 6 buttons. How the hell are we supposed to know what button actually has been pressed? So we went back to the drawing board, quite literally, I think at that moment it was 5 a.m. On a Saturday morning. We were getting slightly tired. But basically what we did is we took a picture of the board. So this was the first time we actually had a proper picture and didn't just look at the board, which is like this size, which became increasingly difficult at that time. And we took an app called Fritzing, which is an open source app that allows you to draw schematics and circuits. And we converted this control plate by kind of walking these paths that you see here and checking the points between 2 to make sure that we really followed the right path by measuring the resistance between the 2. And if it's 0, they are indeed connected. And we turned that into this way more readable diagram. I think you all agree. The main difference between this and this is that we dropped the resistors, or everything that seemed like resistors. But it actually helped us, because what we're able to see here is, even though it's a bit hard, I admit, but you have in the app, you can highlight over the lines and you see which ones are connected, which makes it easier. But you can see a couple of things that were way more useful for us. Namely, also one thing to keep in mind is that LEDs only let current flow into one direction. So if you see the beautiful arrow here, that's intended because it shows that the current can only flow from, in this case, left to right. Most of these were guessed because we knew that, we knew how to control some of them, and we just assumed that the manufacturer didn't go mad and assigned them in different directions. So we assumed that all of them are aligned the same way. But we were able to figure something out, namely actually port 1, 2, and 3 were all power, which explains why the other LEDs didn't light up. And pins 4 to 6 were able to turn these on and off. And pins 7 and 8 were buttons, so that's still not really useful for us. Well, it wasn't useful for us until we actually took a closer look and realized that the fact that it was 5 a.m. made us do some mistakes, namely that these 3 are not resistors but diodes. If you know what diodes are, that's great. If you don't know what diodes are just like LEDs in the way that they only let current flow into one direction, which meant that, well, that explains, that allows us to clear up our schema. We dropped the LEDs because we knew how to work with those, cleaned up the diagram, and had this. And then we finally understood that there was a clear mapping. The clear mapping was that every switch was either between pin 1, pin 2, pin 3, and then 7 and 8, respectively, which explains why in the past we were able to, earlier, to turn the buttons on and off, which we actually didn't. We just put power on them, and that's why they reacted. But this meant that since they're clearly dependent on on the input of pin 1, 2, and 3, it wasn't as easy to sort of just simulate the signal. Luckily, my flatmate had a good point in us hitting up the hardware store before this, and we bought so-called relays. If you don't know what a relay is sort of like a digital switch. Like you have a switch, and instead of having to press it, you can just put power on a certain pin and turn it open and close. So that's what we took, and we wired those up instead of the buttons that we were trying to simulate. So we had, I think, we had 4 relays. We decided we're going to wire up the 3 most important buttons for us, which is on, or like power, and then it's the espresso and the large coffee. And we wired these up, and we wired up the LEDs because we got rid of the control plate, meaning we needed some sort of idea of what the state of the machine is. So this was the initial wire up. If it's 6 a.m. and you realize you don't have enough jumper wires, it's a great trick to just flip the relays and plug them directly into the breadboard. Totally works. Until a couple of months ago, this was literally the setup, until someone at a conference was like, I have some jumper wires with me. So now it looks a bit nicer, I think. But we were ready for our first test run. Again, the nice thing about Johnny 5 is they also had a class for relays. So the code was very straightforward. We initialized the relays. We told Johnny 5 at which pins they are connected. We set them into the type normally open because that's how we wired them up, and then immediately closed them to make sure they are definitely closed. And then we injected them into the REPL, which is basically just a normal REPL that Johnny 5 comes with, which allows us to interact with these things. And then we were able to do a first test. So this is the video of the original first test. So I call grande open here, which basically just should open the relay for the normal coffee. You should see water flowing here. We didn't try it with coffee. We didn't want to waste some coffee. And then we ran close, which stopped it, and the coffee stopped. So yeah, at that moment, 7 a.m., the sun rose already, and we figured, let's close this up. We wired the cable through the outside to the outside and put a sticker on top of it to make sure that it is still very accessible for us, but we didn't have to jam the whole hardware into the device. And we called it a day for that day. But I was talking about making an IoT coffee machine, right? And I was talking about having an API. So far, we have a coffee machine that can be controlled if I will connect my laptop to it and run a JavaScript command, which isn't really convenient, right? I could have just pressed the button. So this is where my all-time favorite status code proposal comes into place, and that's 418 I'm a teapot. How many of you know that one? How many of you know where it comes from? All right, if you don't know where it comes from the IETF RFC 2324, which is the proposal for the HTC PCP. If that sounds weird, that's because it stands for Hypertext Coffee Pod Control Protocol, which was a protocol proposed by the IETF Standards Committee on April 1st, 1998. So obviously as an April Fool's, but it's a great document. I highly recommend reading it. I did, and that was actually shortly before we did this coffee hack, which motivated me to do this coffee hack with my flatmate. And to give you a small overview about it, first of all, it's based on HTTP, so that makes it easy to implement. It adds a brew method because post isn't enough. It is equally treated like post though, so you can interchange the two. It also specifically mentions that brew is not limited to coffee. So if someone of you wants to create a beer brewing protocol, they actually recommended you can use that as well. It also adds a new option for save, so which is if user is awake, to indicate whether it's safe to re-trigger the same request or not. And it adds an accept additions header, which allows you to ask for milk or other additions. It also suggests the status code 418, as I mentioned before, which, as you can believe now, is in case you're trying to talk to your teapot with the coffee pod control protocol, which obviously the teapot is supposed to react with I'm a teapot. So that explains that. And since it's a new protocol, we need a new URI scheme, so there's the coffee URI scheme. It also adds a bunch of other things like new content types, etc. It's a hilariously good read. This is the accept for accept additions. You can see it supports everything from milk types, syrup types, sweetener types, spice types, alcohol types. But interestingly enough, it doesn't specify for all of them the valid values. So spice type is not defined. It can be pretty much anything. I think that was to future-proof for pumpkin spice latte from Starbucks. So totally works with that protocol. My favorite thing, though, is the coffee schema. This is the actual coffee schema. So for the basics, we have the coffee scheme, and then we have the host, a pod designator, which is like pod 0, for example, for the default one, and then an additions list, which you can pass either as a headers or as query parameters. The interesting thing, though, is this massive list here. And if you're German, you see this. The reason why it's spelled that weirdly, it's explained somewhere else in the document, is that they cared very much about internationalization. And since Kaffee is spelled with a capital K, we obviously need to escape that character to make it valid in a URI. So that's why they did this %4b, which actually stands for a capital K. So now the cool thing is, obviously I had to implement this, and I did, and it works, sort of. It's a subset, but it is working, and it's quite cool. So I figured we're going to jump to a small demo here. All right, so let me jump out of this. The first thing is, because the Wi-Fi connection here isn't too stable, I need to redeploy this because I didn't keep it running because it crashes. So what this is doing is basically it, right now it's connected via the cable just so I can quit it. You can push the script straight onto the device and just keep it running. But I'm deploying it now and keep it connected to my computer so we can see if it crashes. and then it deploys it to the memory of the device. And while we're doing that, I can give you a quick look into a bit of the code. So what we're doing here is I kind of factored all the actual coffee machine related code into a different part, but I'm just creating a normal HTTP server. I don't even use an NPM package here, purely to keep the bundle size smaller. And then we have, I use local tunnel to have an externally addressable URL. And once that's all set up, I initialize the coffee machine, and when that is ready, I just console log that. When we handle the requests, obviously I check if my coffee machine is a teapot, because that had to be done. And then additionally, we do things like checking which request it is, so that I can get the status of the coffee machine, for example, which we can do now. So this is just the URL that I have it assigned to right now. The authentication part is sort of very secret here. I had to come up with something that solved a couple of problems, which I'll address in a second. But we can do this get request now, and we get, if I zoom in a bit, we get is on true here. So our server is running. We can see here the get request came in. And yeah, so then we obviously handle post requests and brew requests. We check if the correct content type is set and if it's authenticated, and if they ask for any additions that we don't have. All the kind of like joke things that I had to do, because else it wouldn't be a proper implementation, right? And then depending on the action, we either press power or press the respective button. And we'll look at that in a second. By the way, this is the list of additions, so no spice types for me. And this is where I said it sometimes crashes, because the internet connection crashes. All right, so I'm going to redeploy this, which takes a couple of seconds, so we can look more at code. So this is the actual code that talks now to the coffee machine. So it's pretty much the same code that I had earlier on the slide, just a bit cleaned up. So you see we wait for the board to be initialized, and then once we have that, we create these relay instances, we close them, and then we have press power and press, which are basically doing both the same thing, which is they simulate a button press by first opening the relay, waiting 500 milliseconds, and then closing it. The reason why we're doing that is that the coffee machine has this behavior. If you press a button quickly, it makes the exact amount of coffee that it needs for that type, but if you keep it pressed, it actually does it until you release. So we simulated a button press. All right, so the coffee machine is back up, which means that let's write some code to control it. So I hope you all voted on which coffee we're going to make. This is just some code that grabs it from Twilio Sync, which I use to power the voting. And what we're going to do is let's first log quickly the values. And then we need to define which type we're going to make, which is if espresso has more votes than grande, we do espresso and else grande. And then we need to construct the URL. So I showed you earlier the URI scheme. I had to slightly alter that by adding a sub URL, a sub resource with the respective type, because my coffee machine doesn't have multiple pods, but it has different types. So I felt that was more suitable, but I didn't really think that these machines were even thought of in 1998. So I adjusted this. And then we need to pass our super secret authentication token. And then the last thing we need to do is do the HTTP request. So I'm going to do a post request just because that's a bit easier. We need to pass in start. And since we have to have the correct content type, that's, who can guess it? It's application coffee pod command, because that makes sense. And then we can just console log your coffee is ready. Cool. So save this, execute this, and hopefully, all right, It's going to be an espresso. This is not too many votes. Last time I did this, I had 5,000 votes. But the coffee is brewing, so that worked. All right, so that worked. As I said, like under the hood, this is basically opening the relay and then closing it to simulate it. If you set a bit further to the front, you actually heard the clicking. And now you can smell the coffee. All right. So the other thing that I was talking about was Alexa integration, right? And the way we solved that was I didn't actually write an Alexa skill. The nice thing is that if this then that, so I have TTT, has a makers channel, and an Alexa integration, which means that you can actually trigger skills via that. And what we just did is we adjusted slightly the code here to allow the content type text plain, because for whatever reason, if this and that doesn't support application coffee pot command as a valid content type. And similarly, we added the way that you can pass the token as a query parameter rather than as my made-up coffee authorization token. So I kind of added that as well, and that is all it took so that we can now say Alexa trigger espresso, and it starts making espresso. So far so good. Let me jump back into my slides. Cool. All right, if you want to take a look at the code, it's up on my GitHub, including the scripts that I used to test this, including all the code, meaning all the stupid stuff I tried, mostly commented out, but you can take a look at it, so I'm pretty open with that. Let's talk about what I learned. First of all, reverse engineering is a lot of fun. It kind of got me back into my childhood of opening things up, trying to figure out what happens if I unplug this. And it's great because it kind of connects you back with the technology that we use every day, rather than just taking it for granted. Reverse engineering can be frustrating. We broke at least 2 LEDs on the original control plate by doing stupid things. And the problem with hardware hacking is that you can't just revert the hardware. You know, like there's no version control system for your hardware. So you need to replace it. And replacing hardware at 5 AM is sort of difficult because I don't think any hardware store has open at that time, and Amazon doesn't deliver that quickly. The other thing is JavaScript and hardware work really well together. It was incredibly easy to kind of quickly develop this. It was super nice to be able to just use event listeners to both debug things like the button presses, as well as later kind of take this a step further and when I was implementing the server. Tessel 2 is great. It's a great way for you to get started if you want to do hardware hacking with JavaScript. It's probably not the hardware that you're going to use in every project because it's a bit more pricey. But it is a great way to get started because you have everything in one and you don't have to worry about kind of like having an additional device to it. Johnny 5 is super useful, especially if you get started with the Tessel and you only have one. You can later port that to, for example, a Raspberry Pi Zero or something that is cheaper, and just keep running the same code there. So it allows you to write very portable code. What's next? First of all, we need to programmatically determine the state, because right now all we do is actually keep a flag if the machine is on or not. And the reason why we do that is because the coffee machine and the Tessel have different grounds. They don't have a common ground, which makes measuring if the LEDs are on or off not as trivial as we would like to. And then we need to add more relays to be able to control the other buttons as well, to add additions, etc. And then I'm always up for suggestions. I heard things like adding an RFID scanner to figure out if there is a coffee mug underneath it, or figuring out a way to replace the capsules, because that's a manual process right now. If you want to read through this whole process again and my frustrations while doing that, I published appropriately on April 1st a blog post about this, which you can get on this URL. I'll tweet about that as well. And I put up the slides on this on speaker deck, so you can get that on this URL, but again, I'll tweet all these links after the talk. And with that, I would like to thank you for your attention. And if you have any questions, you got a couple of minutes now before you can all storm to your lunch. So yeah, thank you. Ihr dürft auch auf Deutsch fragen. Ich wollte es nur weniger awkward für alle machen.
Dann sind wir laut über das Mikrofon.
Ja, hat irgendjemand eine Frage? Ich sehe bisher nur Leute, die zum Mittagessen gehen. Ja. Ja. Also es hängt wirklich davon ab, was man machen will. Und dementsprechend hat man gibt es verschiedene Ansätze. Auf der einen Seite, wenn du jetzt nicht unbedingt das ganze Node-Ökosystem benutzen willst, dann funktioniert Espruino echt gut. Die haben halt nur ihre eigenen Module, dementsprechend kannst du nicht jeden JavaScript-Code copy-pasten, jeden Node-Code, den du findest. Und die sind relativ günstig. Wie gesagt, du kannst das Ding auch direkt auf ein ESP8266 flashen und das direkt da benutzen. Ein anderer Ansatz wäre, ich habe vor kurzem einen Workshop gegeben über Nodebots, also quasi Hardware mit JavaScript, mit den Arduino Nanos. Da ist halt, wie gesagt, die Sache, dass du einen Computer dran hängen haben musst, aber das ist zumindest schon mal ein guter Start, um mit Hardware rumzuspielen. Und die andere Sache wäre dann halt, wenn du wirklich was Autonomes haben willst, ein Particle Photon ist, glaube ich, etwas günstiger. Da würdest du dann quasi den JavaScript-Code wieder nicht auf dem Gerät laufen lassen, aber Particle hat eine Remote Execution API und das Johnny 5 Plugin erlaubt dir dann quasi damit zu reden, sodass du dann deinen JavaScript-Code einfach auf irgendeinem Webserver hosten kannst und den da laufen lassen kannst und so dir das Gerät kontrollieren kannst. Oder wie gesagt, wenn du einen Raspberry Pi zu Hause rumliegen hast, wie die meisten mittlerweile, glaube ich, dadurch, dass sie so günstig sind, kannst du auch jeden Raspberry Pi benutzen. Du findest auf der Johnny 5 Website alle Informationen, welche Hardware welche Sachen unterstützt und dementsprechend, wenn du Johnny 5 benutzt, bist du da relativ flexibel.
Sonst noch eine Frage?
Ich glaube, alle haben Hunger.
Ja, da.
Du sagtest eben schon, den ESP8266 für die Entscheidung in JavaScript cool, aber no MCU. Also für den Kontext wäre dann nur, aber die API sieht sehr Node-artig aus.
Ja, nee, ist auf jeden Fall ein guter Ansatz. Kann man auf jeden Fall benutzen. Es hängt halt wirklich davon ab, womit man selber quasi sich wohlfühlt. Also ich kenne auch viele Leute, die mit dem ESP8266 und Lua rumspielen. Ich selber habe es noch nicht gemacht, aber kenne viele Leute, die damit happy sind.
Okay, wenn du den Preis angesprochen hast, das Ding mit USB-Converter ist 14 €.
Ja, wie gesagt, man kann das halt auch benutzen und dann selbst da drauf Espruino flashen. Es gibt auch einen neuen Espruino Puck, das ist ein Bluetooth-enabled Device, das gleichzeitig auch ein Knopf ist. Also wenn ihr irgendwas wie ein Amazon Dash bauen wollt, könnt ihr das auch benutzen. Ja. Ja, das war der nächste Ansatz, aber wir hatten Relais da und keine Optokoppler. Aber danke.
Ja, dann vielen Dank, war ein super Talk, hat Spaß gemacht.
Vielen Dank und guten Appetit.
Ja.